Hello, everyone. I'm David Love. I am a member of the Executive Committee of the National Spectrum Consortium and also a professor of electrical and computer engineering at Purdue University. And I'd like to welcome you to the NSC Tech Talk series. Today's Tech Talk is entitled How Non-Terrestrial Networks Are Pushing the Boundaries of 5G Connectivity. The discussion today will examine 5G in space, low Earth orbit, and high altitude platforms, and their implications on connectivity in both civilian and military environments. Before I turn it over to our moderator, Shane Tews, I just wanted to say a little bit about NSC. We are a 440 plus member organization working with the government and each other to incubate, accelerate, and operationalize revolutionary advances in technology and to inform the policies that make these advances possible. We aim to do this in a collaborative manner. For example, with non-terrestrial networks, we have established a government, industry, and academic working group to identify and provide recommendations on some of the most meaningful challenges in space. Feel free to reach out to me or any of the other executive committee members if you have questions or any kind of comments about NSC or the working groups. With that said, let me turn it over to our moderator, Shane Tews, who is a senior fellow at the American Enterprise Institute and also the host of the Explain to Shane podcast. Thanks.
Thank you, David. This is like an extended version of Explain to Shane, right? I just find things that I find really interesting and I find really smart people to talk about it. So this is fantastic. I really am looking forward to spending the next hour with you all. So let me just give you a quick rundown of who we have on today's program, and then we will just kick it off with some really interesting questions. So we're being joined by Leland Brown. Leland is a technology development manager at Intel, focusing on advanced wireless development and 5G technology applications. Prior to Intel, he worked at the RF engineers at the Verizon Wireless working in macro sites. Bunch of acronyms here, Leland. IDAS and ODAS deployments, high traffic capacity, special event network engineering. You're also an electrical engineer from the Department of Defense, and you received your Bachelor in Science in Electrical Engineering at Lehigh University. So great to have you in today's conversation. We also have Colby Harper. Colby is the CEO of Pathfinder Wireless, a pioneer in 5G R&D standards, non-terrestrial network spectrum sharing, open ORAN, so you've got this all. Pathfinder applies to the global telecommunications development needs. He has led the strategic wireless innovation, early and late stage research and development and operation since the 2G era. I kind of feel like now I wish I had a couple phones we could talk about that, including hands-on designs on novel high-performance synchronization and advanced wireless systems. He's going to have to tell us about that. Special adaptive real-time control complex systems. Colby has served as a founding member of the International Standards Initiative and contributes to the telecommunications policy legislation. Received his BA in economics at the University of Washington. So welcome to the, I'm sitting near Washington. Eric Spittle is the Chief Technology Officer at LinQuest. He is a seasoned national security space professional with nearly 30 years of experience in various government and industrial positions. At LinQuest, Eric develops and manages technology vision and technology roadmaps. He is also a lieutenant colonel in the United States Air Force and has a Bachelor in Science in Mechanical Engineering from Penn State. Last year we have Steve. Oh, Steve, I should have worked on your last name. Vogelsang, am I saying that right?
That's good enough.
Oh, okay. We'll just call you Steve. Steve is a CTO for Nokia's IP and operational networks. Business and responsibilities determine on which projects and emerging markets he's working on, where we should invest, and while helping to develop roadmaps so we can embrace the opportunities that best fit what Nokia is looking to work on. Before joining Nokia, he was the founder at an edge router startup, Laurel Networks. He's a self-proclaimed cynic when it comes to technology trends. Steve likes to cut through the industry hype and get down to what's best for business. He graduated from Carnegie Mellon with a BS in computer engineering. So you are all definitely, you know, we've got the A team here. Leland, I'm going to start with you and just kind of talk a little bit about the historical use of satellites, especially their importance during emergencies.
Yeah, sure. So first of all, thank you for the opportunity to speak to this panel today and to be a part of this panel. I'd like to take it back to the goal, right? The goal is to develop secure, scalable, mobile broadband tactical networks. And that goal goes back to my first time periods at U.S. Army CCOM in the early 2000s. That request was on the table. You know, I could probably open up an OTA or BAA from that time period, and the same requests that we see within 5G now, with more requests back for 2G and wireless LAN and even Bluetooth technologies back then. To the point, when you get down to why we develop cellular networks, each generation has a goal, right? We can talk about the goal for 2G and 3G. We understand 4G provided broadband network capabilities, true broadband network capabilities on the commercial side of the track. And now 5G, which is driving connectivity and platform access at the hyper edge. But I tend to like to draw to a personal requirements for these, right? When you look at the need for resiliency within the networks, there are some key points in history, even recent history, that we still have a struggle with this, right? I mean, I was at the U.S. Army CCOM during the 9/11 attacks on New York and Washington, and I remember primarily my cellular service was completely blocked, or coverage was just gone simply because of the attacks. So, for me, I couldn't reach out to my family, and I was stuck on the base, right? About 10 or 12 years ago, I was in DC, and an earthquake hit somewhere in Virginia that affected DC. I think that went all the way up to Maryland. Again, the networks were either clogged up or damaged. I couldn't reach out to my family. About a few weeks ago, I live right outside of the Philadelphia area, and 8 tornadoes flew through this area. F3 tornadoes. Never seen this in this area. Again, networks went down. Let's keep in mind here, I own phones from all 4 networks, well 3 now, for Sprint and T-Mobile merged, and every phone was down because of a co-located tower near me. Again, I couldn't reach my family. So I see non-terrestrial networks beyond 5G as a call to action, right? And that action is, how can we now take the requirements for connectivity, how can we take the requirements for platform access at the edge, and then provide a level of resiliency to the network? We talk security, of course, that's a major requirement on the federal side of the track, but it's resiliency. And that's the experience that I had. Just the networks are not resilient at this time, and we need to drive those technical strategies and put them into action. Augment the fact that when you look at what federal aspects, or let's say what the military requirements in terms of comms as compared to the commercial driving. I'm sorry. Okay. The commercial aspects, of course, we all know the drive is for revenue and business. That drives the development and then the build out of networks. On the federal side of the track, or the Department of Defense side, it's all about mission. How can you enable mission requirements with your networks, right? That tends to be a little bit of a 180 as compared to what the commercial driving factors are to build out networks as compared to mission requirements. So we need to take into account, not only is it resiliency, non-terrestrial networks will enable some of those mission requirements, and we see it now. It's not that we don't have non-terrestrial networks that exist. It's how can you provide the terrestrial and non-terrestrial networks seamless connectivity with these multiple radio access technologies working together to ensure that you can enable mission requirements.
So, Colby, it seems like you probably spend a lot of time thinking about exactly what Leland's saying we're having to get towards. The think tank that I work for, we have 2 sides. We have the econ side and we have foreign and defense policy. And since I do tech, I'm always edging over into the foreign and defense policy side, which doesn't always make everybody happy. So we're always having to figure that out. But, we've seen definitely with the idea of how we're dealing with the LEOs, and military's had the space pretty much to themselves. They've had issues to deal with, but now we got a lot of commercial players that are coming in. What's pushing the boundaries around the civil and military space, and how are we going to manage some of the friction points on that?
Well, thanks, Shane, and thanks for having me on the panel, and thanks to National Spectrum Consortium. Maybe if we start with what's pushing the boundaries of 5G from NTN, and those are firstly, I think, physical changes, physical constraints relative to the terrestrial network. Very great distances, right? So many times from 2 2 to 3 Everests high in the case of high altitude platforms, to many hundreds or thousands of Everests high relative to the users in the ground segment. Also speed, right? Velocity is a key constraint as well as enabler. We're talking about LEOs going approximately 1,000 miles per hour, give or take, right? And you'll hear a sonic boom at 767 miles per hour, 68 degrees Fahrenheit. These change the nature of what can be done in both the architecture as well as the specifics of propagation, the delays, the latency, the ability to provide certain services in the low latency regime. So as Leland said, resiliency is key, and probably in terms of ultra reliable and low latency or critical communication services. Satellite and HAPS are an essential component of that to meet some of the use cases that Leland was saying. But they do have some challenges in the ultra low latency aspect of them, which is another key. In terms of civil and military coming together, I would say certainly security, that's OBO important. Though beyond that, innovation and competitiveness is key, right? This is both from, how do we continue to open up interfaces so that innovation is opened up for distributed wide area control? Because now for the first time, it's a matter of not just an information space, it's a matter of control of physical space, an interface or a mediation with real-time, low latency control of stoplights, rural agricultural machines, cars, as we all know, autonomous cars, and factories, right? So these are critical, and they're both enabled and slightly constrained by the 5G NTN space. The competitiveness here, I think, is interesting for us all to watch in terms of how the 5G architecture is both disaggregated and reaggregated. And I've been very interested in Steve's thoughts on the dynamics of disaggregation and reaggregation as it plays out in industrial organization, because you've got industry moving on these emerging critical communication spaces, and you've also got government with specific needs. And how they play together over time, how those dynamics play out, I think is a key area to watch.
Steve, do you want to pick up on that?
Yeah, sure. Well, first of all, thank you for having me on the panel today. I really appreciate the opportunity to speak to all of you. To your point about how industry and government can work together, I think a big thing that we're looking at is, with 5G technology, I think we've advanced the technology to a point. Back to your point, Leland, you've kind of been looking for 2G, 3G, 4G, getting the capability set to be able to address some of the use cases. I think 5G really is the first generation where we've been able to target a wide variety of challenging use cases. If you think about, 2G was about just getting good voice connectivity with a little bit of data. 3G, better data, still voice. 4G was the first true data. And 5G is the first one where we've had the luxury to say, hey, look, we've got a data network that works. We can now focus on the more challenging use cases. And NTN is one of those. And we're putting a lot of effort into the standards to get NTN functionality. And we're building that into the technology. You mentioned, Colby, a number of the challenges. You talk about a LEO network and the speed at which those satellites are moving. We've had to do some very specific things to deal with that. There's Doppler shift effects and other things that we're now building into the technology to handle those use cases. And we're doing that with largely off-the-shelf 5G. So we're able to take the same technology that's being deployed at scale for industry and now repackage that to target government applications that maybe are much more specialized, much more tactical, much more challenging in some ways, but we've got the capabilities to do that for the first time.
That is great. Eric, let's get you into this conversation. So there's we're asking these satellites to do a lot, and what people tend to, humans like everything to be about themselves. A lot of what Colby just reminded us is that 5G is really about the machines talking to the machines. So is that, how complicated is that? Is it going swimmingly, or you guys got it all figured out, or where are you in the process?
Well, thanks, Shane, and I'll echo my appreciation of being invited on this panel today. It's a great opportunity. The satellite community writ large is just as technically advanced as the wireless has been, just in different approaches. I mean, if I take us back roughly 20 years ago to the late 90s and 2000 with the dot-com boom, that was really the first attempt to put these kind of services in space, and technically it was solved. The business case didn't close at the time. But the owner-operators have persevered and primarily focused on geo constellations over the last 2 decades and built very profitable businesses. What's really happening is sort of twofold in my mind from what I'm reading from the press and being in the industry is the markets are changing because technology elsewhere is changing. The ability just to broadcast network high definition channels, which is a huge revenue stream for a lot of these companies, is changing as the streaming industry, as a result of 4G technology, has changed user behaviors and habits. And so as a result, those operators have to change their business model. And in large part, they're starting to embrace multi-orbit capabilities, and they're moving towards the ability to merge where 5G is going. And this is why I think this NTN approach is so important for both sides. Because you have a very large SATCOM infrastructure that's in place that's well established and is in the process of accelerating towards both supporting continued backhaul, as well as the opportunity with the price point coming down on the LEO constellations and getting satellites in orbit, provide within the latency of where the standard is going, is direct to satellite, which ties back to the first point that Leland was talking about in emergency situations or for military where you're deployed. Is you're not completely dependent upon the infrastructure, including the power or the local networks of a very small geographic area. You can take advantage of overhead assets, whether they're airborne or LEO satellites, and be able to tie into those with command channels that are hundreds or thousands of miles away and have the resiliency and the capability and security that you need, whether it's for a natural disaster or for military operations. So these environments coming together is a beautiful thing in my mind.
So, Steve, part of this seems to be the ability of spectrum. So, you know, it's an interesting dynamic. I think we've had a lot of people that have looked at spectrum from a new lens in the last, let's say, decade, and realized that there was efficiencies there that we weren't using, but it also allowed us to think really out of, you know, the idea that, you know, using LEOs was really too expensive to be using for commercial, you know, certain commercial markets and coming in. So talk to us about the availability of spectrum, and do we have the right policies in place, or are things going okay, or are there things we need to be changing?
Yeah, so there's a couple aspects when it comes to spectrum that we think about. One, of course, the one that's always focused on is the access spectrum. So what spectrum do you use from a HAPS or LEO system to communicate down to the user devices? There's various strategies for that. It really depends on the use case. Obviously, there is some government reserve spectrum for certain, you know, disaster recovery type schemes. But often, you know, if you take the example that Leland had given, you know, what he really wants is to be able to use his existing handset and light up the existing spectrum that's part of, you know, belongs to the carriers. We have some experience with this. We did some work with the Loon, if you remember the Loon stuff that Google was doing a number of years ago, or actually even till recently. And one of the strategies was to basically create an overlay on the existing spectrum that's being utilized by the wireless carriers. The thing you have to be careful about there is, you know, these systems are spraying a fairly large area, so you run into interference. It becomes a challenge in how you manage it. And then the other aspect, and there's other cases where, you know, it becomes a challenge, but that's one in particular. The other aspect is, it's not often talked about, but you need uplink capacity into the satellite system, and that's where, you know, there's various strategies, but there's not very good alignment across the globe on what should be done there. You know, we've used at times 80 gigahertz spectrum. I think the ITU recommends something in the 39 to 41 gigahertz range that's licensed. The 80 gigahertz is nice because it's not licensed. So, you know, the last thing you want to worry about in a disaster recovery scenario is that you can't get an uplink because you don't have the licensed spectrum available. So there's just a bunch of factors that we're always trying to think about.
So is this an issue right now at the ITU?
Well, I think it's a challenge in spectrum in general to get global alignment on what spectrum is available. This is, of course, for satellite system. There may be some others that have more experience on this with satellite systems than I do. But obviously, if you put up a constellation, you really would like to have similar spectrum across the various regions. I'm not an expert on that, and maybe Eric or one of the others would know a bit better on what are some of the international challenges of spectrum.
It's a challenge at the ITU as well as kind of operationally 3GPP and national regulatory authorities, because the regulatory regimes for space are different than the regulatory regimes for aerial and terrestrial. So whether it's an allocation that allows flexible use, or whether it's simply trying to get within a national regulatory authority, or across ITU, which is a very slow, important, but very slow process of harmonization. Getting the two groups to even align on terminology is sometimes a challenge, and then to harmonize policy. That said, there are a number of point areas where, as we see with some of the new space and existing and still innovating space of SATCOM, they are finding ways to hybridize terrestrial and non-terrestrial. That said, probably one of the biggest challenges there is not just the day-to-day process of moving those into the standards efforts and moving visions at ITU into 3GPP specs, but it's, I would say, probably in this case, extraterritoriality. So this is where, as the idea of you spray a lot of energy, right? You spray a lot of radio frequency energy, and if it's at a river, right, in a valley, which is where you would like to use NTN often, one side of the river might be country A and the other side might be country B, and of course, the energy doesn't know the difference, and yet each national regulatory and each authority and each operator on this list does and cares about that, but Einstein didn't see any difference really between light and RF energy, right? And it's like a searchlight from a helicopter going down there. It's bathing both sides in light or RF energy. So how do we work on that from a policy perspective, internationally, regionally, and within a national regulatory authority? I think is an area to watch for us.
Yeah, I think one point that you need to take into account too is network deployments. How are networks? What's driving network deployments now internationally? Right? We could say that need is driving deployments. At the same time, it's business coupled with need. Right? We're getting to a point where the use cases go beyond necessarily the business strategy in terms of developing networks. And I'll give one example: autonomous vehicles. If we think that we're going to have seamless coverage from deployed networks at this time, whether it be 4G or 5G, it's a mistake. I've been an RF engineer, or I was an RF engineer for a long time for multiple cellular carriers, and I had pretty much the same area where I was designing coverage, and I could state that each of those carriers had similar gaps in service, whether it be coverage or capacity, where I would present the same solution, and all three of them would say no, because it didn't meet the business objectives. So if you think that we're going to have coverage from the terrestrial networks as seamless, well, until we understand that what's driving the build out of those networks is not necessarily need, we have to take into account a solution that non-terrestrial networks could provide, meaning filling in those areas where we may not necessarily have to build out terrestrially. Now we can have the use cases deployed that NTN network can support. Now that feeds back to policy, that feeds back to support of local governments and the central governments in area, both nationally and internationally. But we have to take this into account. We're now getting to a point where it's not necessarily the business strategy that can align up to the needs of the network deployments. We have to take into account now that we have to go beyond that in terms of deploying networks to align up to policy and strategies of different countries and nations to ensure that we have coverage to hit these use cases.
So I take on board the revenue generation for commercial is their primary versus military. You know, they're looking for, they have other objectives, good ones. But I think this most recent discussion that we've had with the administration's Build Back Better program, getting ready to throw quite a bit more money into this space, has shown that we need, and even though there is a particular love, it seems, for fiber with this group, you know, when you go out and look at the areas that are either unserved or underserved, satellite, you know, non-terrestrial could absolutely be a huge answer to the areas that are very difficult to serve. To your point about, you know, when the areas where we're looking at, you know, valleys and hills and places that are tough to be putting actual, you know, end-to-end fiber. And so, you know, this seems like a natural space to go to. Now that we've got the government looking to put potentially part of the bill, depending on how they decide to do the, you know, the build out, do you think we're going to see a lot more people interested in doing non-terrestrial? It seems to make sense to me.
Well, yeah, you know, sorry, go ahead.
I'll jump in. I think the answer is yes, and it goes back to Leland's point in the sense of the business case. When you make the investment in a satellite constellation, whether it's LEO or a large satellite at GEO, you want to maximize the footprint you have and just the physics of how the satellites work or the orbitology when you have a constellation. You're going to be covering those valleys. You're going to be covering that area that fiber isn't easily able to get there, by definition of the business case that you're trying to close. So since you're already there, you want to capture revenue as much as possible. So I think that's a large part of the argument to organizations like the FCC when they're, you know, the Connect America kind of opportunities, and they're putting that out instead of just trenching more fiber. There are NTN services that a lot of those owner operators are saying we already have capability, or it's easy for us to adjust. We can meet that need already, and it supports their existing business case. And that's why I think the NTN organization and our participation on the panel has been very helpful, because we're trying to ensure from a latency standpoint into the standards that that's accounted for to enable these kinds of business opportunities for these SATCOM operators.
Yeah, your comment about uplink versus downlink. Leland, did you want to add to that?
Well, no, I think Erica has covered my points. What the points that I wanted to provide. Just to add to that, you know, when you look at uplink, right? A lot of times we look at, we think of networks, we think downlink throughput, downlink the latency, but the uplink is extremely important for some of these use cases, right? Again, autonomous vehicles, mission, ensuring that you have the ability to uplink and the power. You know, we're talking about coverage, and it's not only comes of frequency, it's power, right? You know, do we have enough power? Can we drive uplink up towards a satellite network with enough throughput and the physics to be able, or to be able to, quote, overcome the physics barriers when you have uplink issues? So that's another aspect to this. But the key thing is, you know, back to the point I was making earlier, resiliency and a requirement for seamless connectivity or seamless connections between these multiple radio access technologies is important. And it's going to take more than just a business strategy. Policy is going to have to come into play. And I know the NSC is strategic for that aspect in terms of researching that. But it's business policy, also mission, and how you're seeing the companies crossing over between the federal and the commercial space, and how we're going to drive this forward. But, you know, we're starting to see that NTN will be a strategic part of the network deployments, both on the commercial side and then the federal side as we move forward here.
Colby, did you want to add something?
Yeah, from the business case perspective, I heard something interesting. Last week I was on a satellite panel at West AfricaCom. And the idea of guaranteed demand from the rural side for rural development, smart villages, combined with energy needs, rural energy needs, farming, and other Industry 4.0 in the rural areas space came up. And I don't know that guaranteed demand, as in guaranteed in part by the government, is even required to close the business model now, because we have lower costs in general, as Eric was saying. We've got terrestrial economics somewhat at play, as well as new space delivery economics at play. But simply smoothing out and aggregating demand might be enough to go a long way to closing the business case. Historically, it has simply not been economic for operators to invest without significant subsidy. now combining and aggregating demand in rural areas in the US as well as globally for international and global development of emerging economies, I think is an opportunity that's unprecedented now. Industrial organization of NTN here, as well as, we're just a handful of policy and technical innovations away from doing this at scale, actually making it happen.
So it seems like we're into another era of really interesting layered connectivity as well, where you're seeing, I mean, I saw Charlie Ergen speak a couple weeks ago, and here's a guy, pioneer of Dish, somebody who's really known as a scrappy player in Washington, but he's taking advantage of knowing what he knows about the satellite area. He's helping on mid-level, and then he's also working with AWS to help with his compute in some of these areas. And so it was just a really kind of unique, different way of looking at it. And then he's actually adding AT&T on in the end when he's got to actually do a transfer over on an area where he doesn't actually have connectivity. So he's kind of thought out all the parts. But the whole idea of how many different layers that he's putting together there, rather than just trying to have a huge footprint in very specific areas, I found really interesting. Do you think we'll be seeing more of that?
Yes. This speaks to the multi-domain architecture that you're seeing, right? That's basically what he's stating is multi-domain. That could be private networks. That could be, the non-terrestrial networks. It's where you're seeing, for example, if you look at a battle space, you may have private networks between soldiers, right? Augmented with a deployment of, let's say, 5G within those private networks. Then you have SATCOM as an overlay for some type of hierarchical data, dissemination, sensor networks and the like. 5G won't be the only answer to all that, right? You're going to have Wi-Fi included into that, right? You're going to have, within the sensor networks, you may have some level of, 5G network deployments, even down to the drones. You may even see drones become more part of a lower orbit or a lower layer communications architecture. All of this has to work together. No way we have one specification that will handle that. Let's face it, we all live in a multi-wireless world now. Probably everyone on this call is on a Wi-Fi network. I'm actually on the cellular network now, but most people are on a Wi-Fi network. Okay, when you leave your house, you seamlessly go over to, let's say, 4G or 5G. You don't know. 5 years ago, you probably had to change something on your phone, but you walk out and you go into a 4G network, right? That's a multi-domain. You have a cellular domain and a Wi-Fi domain. I can even add into a Bluetooth domain if I want to get down to be really specific. But, we live in that now. Now, take that and expand it. This is a way that we're going to have to, provide the capabilities for these use cases that we're looking to deploy in the future, both on the commercial side and the federal side.
I think that's a great starting point, but I think the challenge for Department of Defense isn't just making the connection. Of course, to achieve mission, they're concerned about security and resiliency. Is there intentional or unintentional interference or jamming or congestion? And so what you just described, Shane, about what Mr. Ergen is doing, I think is brilliant from a commercial standpoint, and Leland is spot on. That is exactly the analog of what DoD needs to do from a connectivity standpoint for multi-domain operations. The real question then is, what security standards really have to apply for DoD to use it? There's a lot of discussion about that now. Is 5G commercial open standard sufficient, or layers over top? That certainly has to be worked out over time. There's certainly a lot of pros and cons to each. I think that the challenges for DoD as they get to looking at implementing these kinds of networks is to add additional security, but not do it in such a way that it inhibits the benefits of the open architecture that the standard brings. And if you can find that right balance, then you really have the best of everything, and both from a natural disaster, some potential commercial applications, but certainly most importantly for the Department of Defense use.
That's a great point, because it seems like if you have all these, we're trying ORAN it's great in concept, and actually Charlie is bringing ORAN to the table. I think he's lighting up in Las Vegas in a month or two. So getting somebody who's going to be able to, we can go watch his Petri dish and see how he's doing there. Eric, I think when we talked earlier, you were talking about there are two types of speed And latency obviously is really big because we've all gotten very selfish. We expect everything to work all the time very quickly. So could you kind of elaborate on that? I believe it was, you were talking about gig speed versus, and I didn't write down the second part, so I'm really curious to know what it was.
Well, I think a lot of the challenge for some of the constellations at LEO is really providing low latency for connectivity broadband, whether it's 5G. And if you really start to look at the proliferation of these architectures compared to the delays on terrestrial fiber, depending on all the stops you go through and how direct it is and delays and so forth, I mean, you're starting to see the qualitative assessments starting to collect some empirical data that proves that in certain applications, the further apart you are, actually going non-terrestrial network to LEO can actually be faster. And in certain banking and other industries commercially, that is extremely important, not just for gamers, right? That's always something that's thrown out there that they want the lag, but really for a marketplace kind of transaction, that can be important. It certainly is very important for multi-domain operations for the Department of Defense and military utilizations, and even in emergency disaster to some degree, if you're trying to respond very, very quickly. So I think even though there is some propagation delay, incorporating that into standards, depending on the circumstance, actually can achieve an overall faster response than just purely terrestrial networks can in certain circumstances.
And Steve, I want to go back. You mentioned Project Loon, and this is an open curiosity I've had that didn't. I know when we had the hurricane in Puerto Rico probably about 4 or 5 years ago, they brought the Project Loon over from Colombia to Puerto Rico to help light up Puerto Rico while they dealt with all the damage on the towers. And I believe that, from what I understood, what limited public information, it went pretty well. And then at the beginning of this year, there were issues with Cuba, and there was a call by some people in the government to say, can we do something similar over to Cuba? And I was trying to explain, my little limited understanding of this is that you have to have the capacity of a device in Cuba to be able to use the Project Loon to actually be able to help connect the people. Did I get that right?
Well, I mean, you definitely have to have, as I said, the uplink into the constellation of, in this case, balloons, and that may have been the issue. I'm not super familiar with what was going on in Cuba.
What happened in Cuba? They didn't really talk that much.
Yeah, so that could have been the issue. It may have, I don't know, maybe they weren't available to deploy. There's probably other factors involved. What's nice about that type of system is that it is compatible with existing devices, right? So when you move to something like LEO at that altitude, you really can't use your existing, you can't use your existing cell phones, right? You need some type of device that has higher power that can actually reach into the constellation of satellites. The HAP systems are nice because they can work with a much wider variety of devices. Of course, the challenge is they're costly to keep in the air, right? Whether it's drones, whether it's winged aircraft, balloons. Balloons are challenging. So you can't really. Google did an amazing job of actually controlling where they go by increasing, decreasing altitude to get into different wind streams. But that's costly. You have to keep something aerial in place, relatively in place, for an extended period of time. So I think for tactical use cases, for disaster response, those systems are really nice because they're compatible with the devices a lot of people will have on the ground. But for a long-term broadband service that you're trying to monetize, it's just not economically viable, right? It just costs too much to keep them in the air.
Yeah, it does seem like it's a good emergency entity to have in your capabilities, though.
I will take a little exception, though, to what you said, Steve. I mean, there certainly is at least one LEO startup who has been able to have a 4 and 5G device connect directly to the demo satellite. But technically, to close the link, you do it on both ends. And as the satellites are designed, if you design it up front with the receive sensitivity, with a larger aperture and power density on the broadcast, that's certainly an approach that can close with existing devices. To what degree and to how much throughput, again, the economics will determine that of where it goes over time. But it is not a non-starter to say that you can't have an even existing device that could be able to close a link with LEO, which a few years ago just seemed like it was impossible. But again, the technology particularly in the space domain, which is leveraging all the commercial innovation, is changing so rapidly that even those seemingly impossible capabilities are being realized today.
Yeah, I'm actually glad you brought that up. It's a good point. There are people attempting to solve that problem. We're actually demonstrated it can be solved with a big enough aperture on the antenna. So yeah, very, very good point. I'm glad you corrected me on that one.
So it sounds like technically, I'm sorry, Colby, do you want to add to that?
I was going to say, and I think, Steve, something you said earlier in terms of HAPS, right? Having kind of an intermediate role, perhaps, between the LEO layer, and I mean, there are multiple spatial shells, right? Yeah. We have LEO in part because it's 100th of the delay of GEO, in part. We have HAPS not just for of the various sorts, not just for emergency, disaster relief, disaster recovery, et cetera, and tactical needs, but also because of an extreme low latency capability, right? So you can hit at least, we'll call it very low latency, if not ultra low latency capability with a HAPS. You can't really do that with a 300 kilometer up LEO or very low Earth orbit. So a role for all of these spatial shells, essentially, whether it's space, wherever you call the Kármán line, below that HAPS, and then even tethered UAVs, right, from an economic perspective, and over the horizon type communications for military and island communications, right? I think they will have a role, and mother necessity will drive some of this. Of course, when and where does it make sense economically and technically? I think folks like you three and your organizations, and Eric's concept of where there's a need, we'll develop the technology.
Yep.
So
totally agree. I mean, all of these come together to build better comm systems, right? It's not a one size fits all. They have all got great properties, and I think we're getting smarter about how to put them together and leverage the various capabilities.
And to your point, Colby, I think the layers are all opportunities. We'll find out if commercial profitable business can be done at all of them, but where not, again, for emergency needs or military needs, which again are not focused on profit and revenue, they could augment with a different layer just to solve a particular need because there isn't a commercial service. But as long as the standard enables it, it still allows the capability to come online.
Yep.
I'm a little bit, so I was one of the early HAPS representatives in the 3GPP RAN. So I'm a little biased towards HAPS use cases, to be fair. They're further out than we think, but not so far out, I believe.
Yeah, and also I think if you take into account the requirements for Converge management of all this, right? We're talking about having UAVs that are tethered. So there's some level of traffic management that's coming into account. This isn't necessarily a wireless discussion. It's a management discussion of all this, just in terms of frequency, but in terms of deployment. If it gets to a point where you have a bunch of UAVs that are tethered in order to adhere to whatever non-terrestrial network requirements that we're looking to in terms of the physics to have devices be able to connect up to the satellites. Now you're getting to a point, well, when you deploy these UAVs that are now tethered, how do you manage that deployment? How do you manage the traffic management for this, right? You have UAS. Of course, you have counter UAS from a military perspective, but then you have unmanned traffic management, UTM. Well, how much of that could come into play now if we're getting into that layer of the shelving of different NTN networks?
So a lot of work done by the engineering on the technical side. How are we doing on the policy side? Do we need to catch up? Are the policies lagging, or are we feeling in pace with all this amazing innovation that's taking place here?
Well, I mean, point solutions in terms of policy point solutions from a spectrum regulatory perspective, yes, right, it's keeping up, it's making some choices. It takes time to move it through. But in terms of general frameworks, it's not, it has some catching up to do, I would say, particularly in the spectrum sharing regimes. That said, as an ecosystem of national and international regulatory authority regimes, I would say that they are in an innovative mode. They're in the middle of, I'll use the term as, inflection point themselves in terms of whether it's upper microwave frequency, flexible use here in the US or elsewhere. There is just some creativity in the world's regulators that hasn't been there, that wasn't there 10 years ago for sure, and is there now. So the opportunity is there, they have catching up to do, and I believe it is on most of their agendas.
Yeah, I would say that the technology development was always aligned to the policy. Now it's the deployment of the technologies that may be ahead, right? We're getting to a point where, for example, frequency. You have military requirements in terms of frequency access. You have commercial requirements, but who owns the frequency? The commercial carriers, right? Having access to the frequency has to be some level of policy. That's why a lot of the experimentation that you saw out of the 5G RPPs, so some of those were geared towards dynamic spectrum access or dynamic spectrum sharing. Well, that's a technology development, but it's really aligned to the requirement for policy in that area as well. I can recall working with the cellular carriers where we would, quote, have access to a frequency that was sold, but had to wait 2 years for the military to move themselves from that frequency. And we had to wait because they have mission requirements, right? At the same time, if you have a carrier sitting on that same frequency on the other end, does the military have the right to come in and say, hey, my mission requires access, and then trumps your, commercial requirements to have access to this frequency? So policy along with technology now is the key. So the deployment of it to me is ahead as compared to the development of the technology when it compares to policy requirements.
I'd also say policy and policy coordination among the international governing bodies, we touched on that a bit earlier, is how harmonized are those decisions, because they'll have implications on how the networks are structured, who has what access to spectrum, and what does that mean for both the terrestrial and the non-terrestrial networks interoperating, as we had sort of that analogy earlier with the river and the valley of two different countries. If they license different spectrum, you could be trying to control the physics in a way that isn't really practical to make sure that you're not touching a certain frequency on one side of the terrestrial territory versus the other, because they didn't license the same frequency for what you're trying to do. So it's also, I think, important for the governing bodies, to work through the ITU to collaborate and get as close as they can on these decisions, which just, helps all of humanity in that regard.
Just want to remind the people that are watching that we do have questions. We're going to go into Q&A in 3 minutes. But right now, it looks like we don't have any. So if you want to populate that space, let me know. So you guys work together in a NTN working group. Is that what I understand? Is that how most of you are familiar with each other's work? Or tell me about that. No.
I'll just, well, LinQuest is involved in the national, the NTN non-terrestrial network, and again, part of our focus being a SATCOM background is to try to bring that expertise to the working group and collaborate on the standards in terms of what does that mean for satellite operators and what physically can get done, at the physical layer, and how do things like the Doppler shift that was mentioned and the latency affect into the standards to make sure that it's incorporated. But there's great collaboration and cooperation, so we're very pleased with the opportunity to support.
Anyone else on the working group want to have any thoughts?
Yeah,
go ahead.
So the opportunity for an open forum, relatively open forum for government and industry and to some degree academia, have the conversation about needs and potentials, as well as a pre-competitive conversation across very competitive traditional defense vendors, as well as newer, different vendors like Nokia and others, I think is super valuable, right? Because you don't always have a forum to share that openly and consider what these recommended best practices ought to be in a real-time sense. So that's been, I feel, very valuable.
Yeah.
Oh, sorry.
Well, I was just going to mention within the work group, one thing I would like to bring into play is, when we talk 5G, we're talking connectivity along with the proliferation of compute, right? We're bringing access to the edge, hence there's more compute points. I would say we may get to a point where we're one-to-one with connect points and compute points. How does non-terrestrial networks fit into that? Are we talking more of a coverage solution here, or a coverage and more proliferation of compute through non-terrestrial networks? That's a discussion that I would like to see panned out here. When we talk latency, is really the driving factor, or the driving technology now is how can we bring more platforms to the edge to reduce latency. There's been studies that's really the solution. So there's only but so much that you can push down the wireless pipe before it gets to a point where it's just overcapacitated. So having more compute points at the edge is key. How does that feed into the non-terrestrial network discussion?
I'm just going to point you guys, wait and see what Charlie Ergen's up to. He talks all about that. Steve, did you want to add something?
Well, just on the NTN work group, I mean, I think there's a lot of value in these working groups, and I think the others have mentioned, a number of ways. It's valuable to bring folks together from different perspectives to work on problems, or even better articulate and understand use cases. Sometimes we don't even know the real use case until we get together in those type of forums, and that's where you start to really understand what we're trying to accomplish. Yeah, so just wanted to add that, but that's all.
No, that's great. I think, Leland, to your point, I remember when 5G was first rolling out, people were getting really excited and they were kind of waiting for the advent of it. And then you'd look at some of the use cases, and I talked to several different groups that would say they figured out how to do it on 4G while they were waiting. They're like, well, wait a minute, man, we can just adjust a few things. But a lot of it was actually more of a geofencing. How do you manage it within warehouse organization? Something they were looking at doing at IoT, and they kind of rethought their old process with some of their current technology and just some adaptation. But we'd all like to have less latency. I mean, you're still not getting that with your probably. So
yeah, we could have a whole conversation around 4G and this, the release 14 capabilities as compared to release 15, but that's another discussion.
Quote Monty Python, it's not dead yet, right? So our first question is, can you discuss the DoD management of narrowband satellites? Thinking, Eric, that gets thrown to you.
Management. I'm assuming the question may be coming from some recent press about the Space Force and organizations moving into Space Force, as opposed to historically, the United States Navy has been primarily responsible for narrowband communications, and recent press indicates that those missions are being transferred into the new U.S. Space Force.
Everybody wants to be an astronaut. Okay.
Guardian.
Right.
Space Force Guardians, yes.
So the iPhone 13 could have satellite connectivity. How do you see that moving forward? Maybe not 5G capable, though. Your thoughts?
Well, it's a narrowband in the service as well as the actual bandwidth and throughput. Right? So narrowband communications and narrowband IoT, for that matter, are under the 5G. Now it's been taken under the 5G fold, but it's not the 5G new radio modem. Right? This is fairly simple, text and voice, as you've seen, whether it's Iridium or others in the past. But it's, of course, with a newer service and kind of a fallback when needed.
Okay. Let's see. NTN first responder emergency response applications are described in ETSI TR 103611. Are you considering a new use case for R18? And I could just be speaking French here. So, did anyone understand that? I feel like
I think the answer is probably yes, because there's a lot of stuff that goes into each release, and I'm sure there are use cases for NTN that are in R18, but I'm not a 3GPP standards expert, so I honestly couldn't tell you what they all are.
All the section numbers, okay. We had somebody want to know where your slides were, and they wanted a copy of them, but we didn't do slides, so it's not an issue. So that is it for our current questions. Any last thoughts from each one of you panelists? I'll start with Leland. You're first on my group here, so.
Sure. As I mentioned, I believe that non-terrestrial networks is really a call to action. And feeding to the point, like when you develop specs based upon need and use cases, right? 5G, the development of 5G was based on, as was mentioned, we have real broadband in the hand now, right? Netflix and YouTube wouldn't exist if we didn't have broadband in the hand. How do we reduce latency and ensure connectivity on a terrestrial level? Massive connectivity with multiple different, types of devices. I believe the call to action here for non-terrestrial networks and beyond 5G is to ensure that we have coverage and a level of capacity to ensure that we meet both commercial coverage requirements along with mission. And we're seeing this crossover, and we will continue. The lines are blurring between the commercial and the federal space. And honestly, I think the National Spectrum Consortium is a primary example of that. We have members both from the traditional federal member side and the traditional commercial side of the track working together on solutions. Can't think of any other time that I've ever seen that in my long time in this industry. So great to be a part of it. Thank you.
Good time to be in the industry. Steve?
Yeah, well, first, thanks again for the opportunity to jump on this panel, and some of the thoughts that Leland had there, I totally agree. I think what's happening out with the NSC and the use cases and really driving this, I think we're starting to really scratch the surface of the 5G capability set. NTN is a meaningfully large part of that. It's one capability that I think we can do much more with, and we will do much more with over time. But to me, it's exciting that we're taking a technology that's really built for industry and finding ways that we can leverage that technology into a bunch of use cases that are specific to DoD and others. So it's exciting times. I'm really excited about it.
Eric, how about you?
Thank you as well. I've enjoyed the conversation today. And I would say what to me is exciting about this working group with the National Spectrum Consortium is you have willing participants. The traditional terrestrial network community realizes as the market's changing benefits of expanding access and networks. That's the non-terrestrial network community, both what has been there as well as the emerging part of the space sector and HAPS and so forth. They're also willing participants because they see their markets changing. And so both sides are coming towards this with seeing opportunities for revenue and business growth. And if that's going to help commercially, naturally, I think civil and military applications can only benefit from this arrangement going forward.
Colby, you get last words.
Thanks, Shane, and thanks to this panel. I'd say maybe two things. I agree with my other panelists here. Two things is get involved in 3GPP. Things move really fast, surprisingly fast. For instance, last year at a DOE 5G for Science workshop, we identified sensing as a priority and kind of out there a little ways, joint sensing and comms. Well, Release 18 right now, it has teed up a possible Release 18 study item, to pave the way for Release 19. And Release 18, will run what we call stage 2 or functional until first quarter of 2023, there's opportunity for all of us in NSC, as well as others, to get involved there and have our voice heard. And that's just crucial. It happens there in many ways more than most forums. And then the second part, really, I would say, just this opportunity is great. It is exciting times for commercial and military applications, but also there is really no reason to not have rural development come right along here for the first time. It's going to be relatively inexpensive, very doable, and we can make it happen.
All right, David, hand it back to you. Thank you, gentlemen.
Thank you, Shane.
All right, thanks. So that concludes our Tech Talk on non-terrestrial networks. So on behalf of the entire National Spectrum Consortium, I'd like to thank Shane and all the panelists today. It was a really great discussion. It's given us a lot to think about. I'd also like to thank all of the audience members who attended. If you're interested in doing a deeper dive into any of the technical and policy topics that occurred today, please consider joining the NTN working group of the NSC. And there's more information on the web on that. Also, please be on the lookout for information on the October Tech Talk. The topic of that will be artificial intelligence and network design. So once again, thank you for attending.